Thanks, Tim. Now, modern is a really interesting word. It's not like anybody wants to build the medieval data stack. We're always focused, though, really on what's next and the next thing we're building and how to move ahead. And I think there is something to this language, and I'd like to take a look at it. In the past few years, the term modern data stack has become very popular. There's vendors and open source projects, and everybody seems like they're trying to take control of it, right? Everybody wants to define what it is. And I think this is good as far as it goes. Needs change, tool sets change, technology evolves. I mean, application stacks have been totally upended in the last 5 years. The data upheaval began, I think 10, 15 years ago before now. But I'm going to argue that concentrating on the modern data stack has caused us to lose focus. Before we get to this modern data stack and what it is and what it isn't, maybe it's worth a look back at its predecessor. In other words, and I realize this is very on brand for me, we need to do some history. Let's look at what pre-modern was, what came before, what disrupted it, and what modern really is. Now, let me suggest that the medieval or pre-modern state, whatever we want to call it, is the data warehouse, the Kimball-Inman kind of ecosystem. Or I guess in the Kimball case, that would be the Kimball dimensional data warehouse and Inman data marts or whatever those controversies were. That's the data stack that we're leaving behind. And if you were building these things 15 years ago, I mean, you may know a lot about this, but some of you may not. So this picture here is the basic Kimball architecture. And there was, as I hinted, kind of a holy war between Ralph Kimball and Bill Inman, and these subtle distinctions between things that, at the level of this block diagram and with the benefit of a little bit of distance, they're beginning to seem fairly esoteric, these distinctions. But hey, they were important things at the time. You had this basic idea where there are these, we'll call them departmental databases. That's the sources of transactional data out there in the enterprise. And it could be things other than databases. Then there's this ETL process. Then all of this transformed data lives in the data warehouse where it's queryable. So this was, at the time, massively value creating. We look back on this, and I'm calling it medieval. It's like I'm poking fun at it, but I'm not. This was a huge innovation, very important thing, created a lot of value. A lot of businesses did a lot of good things, and consultancies were born, publishing empires, all that kind of stuff, right? So it was a great thing. Important distinctions. There was a separate database for analytics from the databases in which transactional activity took place. There are important technological and frankly even mathematical reasons for that I won't elaborate. There's always a separate database for analytics. And that warehouse database in the middle had its own different, and I'll just say for now, weird schema that was different than the operational schema out there in the world. So now you have a second schema, depends on the first. It's this second set of rigid constraints that's kind of a pain to manage because, well, let's be honest, schemas always are, even though they're necessary and good as well. That ETL process that took the data from out there and got it to in here, that was either bespoke code or some expensive tool, and a batch process, a fundamentally batch process that usually ran at night that did all that transformation. And this needed to change for a lot of reasons. As time wore on, the batch nature just didn't work anymore. Now, something disrupted this. Of course, a lot of things disrupted this. There's a lot of factors working together. And I'm using this modern and medieval language, kind of borrowing language from European history. And people are going to argue about what ended the medieval period and began the modern period. Some would say the movable type printing press. Some would say the Protestant Reformation, and all interesting debates. Whatever. In data, it was Hadoop. Hadoop happened. And Hadoop's whole reason for being, the reason it emerged out of Yahoo, was data suddenly was big, and we needed a new kind of infrastructure to handle what we called big data. That was its whole appeal. And it did that, right? It successfully now was able to manage gigantic data sets. But a very important thing that it did, apart from that, was changing the schema question. Instead of that big, rigid set of weirdly formatted snowflake schemas inside the data warehouse, now, to a first-order approximation, we dump data into Hadoop, what we would come to call the data lake, and figure out the format when we read. In other words, ETL became ELT. Instead of extract, transform, and load, now we are extracting, loading into, at first, HDFS, later what we generally call the data lake, and we transform afterward. And this remains an enduring principle. You're going to hear this a lot, this ELT thing, in discussions of the modern data stack, even as Hadoop proper is, not being used for new designs anymore. It's a part of history now. And honestly, that ELT thing is a huge oversimplification, okay? Transformation happens. We might more precisely say ETLT. That's a little less snappy, but sometimes that transformation happens when we're coming into the data lake, and then sometimes we do transformations on read as we're querying. And it just varies by context, right? It's kind of a decision about where to put those compute cycles. If you're going to be querying something a lot, well, you might want to transform it before you store it, and then you can just query it in its raw form. If it's something queried rarely, then you can just do that transformation on query, pay that price there rather than paying it ahead of time. It's a thing that depends, and I guess the point is there's a lot of subtlety here, and I hate to just gloss over it with cool swappings of the letters. In any case, what did Hadoop do? Well, a few things. Data infrastructure now is a distributed system. That question has been answered. Hadoop really was, I would say, the beginning of that movement in a mass market sense. And are you using SQLite today? Yes, you are. Okay, it's in mobile apps on your phone, it's in native apps on your computer. But really, in terms of data infrastructure is distributed. Hadoop kicked that off and made it happen. Data, we don't really say data warehouse so much anymore. It's more common to say data lake, and that's this place where we put the data in order to transform it later. In general, it's a place where all our data lives, and we don't have to do as much work on ingest as we used to. Hadoop also gave us a very complex ecosystem. Literally, the Hadoop ecosystem itself became that zoo of all those animals, and its children, Spark, Trino, Presto, a dozen, 24 other things, its direct descendants are now there making this ecosystem complicated. And on ingest, on read, there's just a huge number of things. And that's kind of a legacy of this explosion. Really is remarkable for Hadoop. If you think about it, didn't last long as a thing that was actually being talked about and used and built into new projects. But it's just had an incredible legacy, made a big mark. Also, it was fundamentally a batch-oriented technology. There have been, in its children, various streaming adaptations that have happened, but that bias didn't really change. ETL, the old-style data warehouse, was a batch technology, and Hadoop sort of kept that legacy. So, with that, let's look at the current state of affairs. What is the modern data stack? And I wanted to look to the community to see what folks were saying about this. What are we saying the modern data stack is? What do we mean? And so I did a very simple thing. I found some top viewed videos on YouTube, some presentations from, leading figures in the space, and I took screenshots is what I did. So here they are. This is from, July 2021, Nas Redev, one of the co-founders of Infinite Lambda, his picture of the modern data stack. You can see you still have sources over there on the left, and note now that these are all kind of cloud sources. They're not just databases lying around the enterprise. A lot of the data has moved to the cloud now. We ingest, we store in a data lake, or maybe call it a data warehouse, and then we extract it and view it in other places. So you still have that kind of three-part system. This is from January 2022. The famous Seattle data guy in a video he made called What is the Modern Data Stack? Tremendously more detailed diagram. And I've shrunk it down here. It's a little unfair. It's hard to read that writing unless you stop and zoom in. But he's just showing a lot more detail of different particular products that can be in there, but you still have the ingest, store, and transform. And that, by the way, that ETLT pattern becomes a lot more obvious in his diagram. And then you bring it out into places to look at it. So there, another view of the modern data stack. Here may be somewhat more elemental. This is from Tristan Handy, founder of DBT Labs. This is from sometime in 2020 he gave this talk. They were called Fishtown Analytics back then. But this is from a talk called The Modern Data Stack, Past, Present, and Future. You see very clearly, you've got mostly cloud data sources. He's got a Postgres on there. So, you've got some of your own applications. Bring it into the warehouse, which is just another word for data lake in this case. They're kind of becoming blended. And then you view it in, the contemporary tools for viewing the data in the warehouse, so that here it is, ingest it, store it, view it. So I'll oversimplify. We've got our data sources. Those arrows are ingest. There's the data lake, and that's, probably S3 these days, right? That's probably files in S3 or another cloud blob store, the cloud blob store of your choice. That data lake abides, and we get that operational data from its sources, which are, I've just picked some cloud sources, some databases that might be out there in your enterprise, old legacy things, and every internal application you build, right? That's key. That little nondescript, not very interesting box in the lower left. We're going to take a look at that again in a minute. All that data from all those applications, we bring that into the lake, and we've got all the possibilities for looking at that. Looker, superset, redash, build your own thing in D3, whatever you might want to do. So when you look around, when people say modern data stack, they seem to mean this. And each one of those components changes. The sources change, the ways we ingest, the ways we transform inside the warehouse, the way we visualize, all those things are in constant flux. And a changing data landscape is no cause for alarm. Our landscape always changes. We only really have brief periods of stasis in the world of software development, right? We pick times to focus on different things. I mean, networking and application architecture didn't change a lot in the early 90s. We were figuring out how to do toolbars and buttons and GUIs. Then the web happened and we retooled. We thought about networking for a while, but then back-end application architecture, frankly, didn't change, and UIs actually got a lot worse for a few years. Then we focused on web UIs and didn't have a lot of innovation in data or application architecture. That stuff spent maybe a decade being stagnant. And then databases exploded. 2010, we started really focusing on that, right? So we have periods of stasis and we kind of focus on one thing to change at a time. Something is always changing. That's not bad. It's not a problem to say that the modern data stack seems to be a slippery thing that is always in motion, because that's what our world always is. So change isn't the problem. The problem is not seeing through it. And I mentioned at the beginning, this word modern is kind of suspicious, right? It carries with it a sense of having arrived, right? You're finally at the good stuff. Whatever came before modern is primitive and unfinished and vaguely embarrassing and polite company. And once we're at modern, well, okay, now everything's good, right? We've left the old and busted behind. And honestly, this is why I try not to use this word in casual conversation if I'm referring to something that's happening right now. I prefer to say, contemporary, because that just means now in an unbiased way. Modern carries a lot of freight. And trying to find the one modern data stack is unlikely to succeed in the sense of converging on some kind of stable knowledge. Like I said, our technology context, certainly our business context, these things are constantly changing. And I think when we talk about it, when we say modern data stack, we tend to mean the stack I'm using right now. And, there's something good about this, right? I think a lot of presentations that are more like experience report type presentations, where people say, hey, modern data stack, they point to the thing they just built in the last 18 months that got them the promotion and launched some new product and some impressive business results. And there's nothing bad about that. That's fantastic stuff that the community is doing with data. But there's nothing final or generalizable about that. That's an example of what a person built. They've got their set of problems and their tools available to them, and they need to know what those problems are and how those tools work. And they're focused on what they're building now. And actually, I think that's exactly right. This creates a very different focus. If you think of it that way, what are my problems? What are my tools? What's available to me to solve the problems I have in front of me? A very different focus than trying to think about what the stack is or how to get the stack right. So go back to this. This is my extremely oversimplified modern data stack, right? Let's remember what we're trying to do. Most of the modern data stack thinking is focused on internal analytics, right? Creating actionable insights to give to internal stakeholders to make better business decisions. So they can make better decisions. Great. Let's do a lot of that. But where's all that data coming from again? Applications. And why do we write applications? Because people use them. People use tools. The tools we build for them. And you absolutely have to ask architectural questions about how to build those systems and how to design the data pipelines that take the application exhaust and make it understandable by business decision makers. You have to have all those architectural questions and think about all those tool sets. And the currently desirable set of choices will always be in flux. It's the task of the architect to do the best job that they can at that right now. But the focus on the stack is an over-focus on a thing and an under-focus on the people who benefit from that thing. Ultimately, you're not going to get paid for writing software. Investors aren't going to fund new ventures that don't make something that people want, or something that, if I may, something that helps people, if we can trust people just for the time being to want things that are helpful to themselves. We can leave that conversation for another time. But that's kind of what you have to do. You got to make stuff people want that serve the needs of people, not that is the correct stack. So this pushes us relentlessly back to the theme of this conference, real-time analytics, and to, frankly, Apache Pinot, which is the technology I personally focus on the most. Real-time analytics, and but this is my LinkedIn page, there are Pinot queries happening all over this page, just to load this, right? Real-time analytics is fundamentally about powering applications with the data behind the business. So we take what's happening in the world of the business and we expose that to users in real time. All this talk about the modern data stack is about getting data from the transactional systems, the real world where that stuff is happening, to the places where we can see it and understand it. It's about, real-time analytics is about, in the moment, answering the question, how can we help you do what you want to do? How can we share what's true about the internal state of the business with you in such a way that your experience with us is richer and more valuable to you? That's really what's happening here. And this requires infrastructure, requires architecture, and all that stuff. But the focus is on the people and the applications we build. The focus isn't on getting the data stack right. And you couldn't focus on external people before. Technologically, tech like Pinot wasn't there. I mean, remember what the big data revolution got us? It got us scale and data lakes and all that. Hadoop was such a revolutionary new capability at the time, but a lot of what seemed like a capability then is now a limitation. It would be like going from a Gutenberg printing press, movable type printing press, to a laser printer, or frankly to WordPress or Next.js, right? They're all the same idea, but with very different performance characteristics. That's the difference between those. That's the difference between something like Pinot and the previous generation of more batch-oriented, as I say, the children of Hadoop. Imagine trying to get your ideas into the world with an actual printing press, or building LinkedIn or DoorDash or any of the other emerging real-time analytics use cases with the batch technologies that we inherited from the previous generation. It just wouldn't work. And I mean, to honor these things, people still use printing presses, right? So this here is a direct descendant of a Gutenberg printing press. It's an early 20th century thing called a letterpress. And these are used by artisans and craft people now. I've actually visited this one. They have names. It happens to be named Dorothy. And it's used by a dear friend of mine who's a wedding stationer, right? That's where this technology has gone. But where we are, trying to use data, trying to understand what real-time data really is doing to us, I think what we need to know is that there is no one modern data stack. There just isn't. There is only the application that you're building. There are the tools that you have now to build that application and manage its data. That is always a complex discussion with many technologies on the table, many difficult choices. I'm not trivializing that. There's still hard architectural work to do there with those tools. But the fundamental focus isn't on the right shape of the diagram and the right vector of tool selections. The focus is the people that you're serving. Real-time analytics is laser focused on serving those people. So go find the most valuable way you can do that now. Thanks.